Hey everybody, my name is Luke De Oliveira. I'm a tech lead manager within the Llama team, within the Gen AI org here at Meta. And I'm really excited to be here to talk to you all about efficient AI, and in particular how we view the Llama stack adapting to a world kind of with efficient AI at its core and enabling AI on any device or on any application. So I'm very excited to be here. I get to tell you about the 1B and the 3B models that we announced today as part of our latest release, Llama 3.2. These are small but mighty models. And we're trying to make AI more accessible and more affordable across a wide variety of use cases, and really unlock things that haven't yet been possible within the herd of Llama models. We are so excited for you to all get your hands on them and start building. With these models, we're enabling applications and use cases on mobile devices, edge devices, and more broadly, places where you need to be mindful of computational constraints or empower privacy-first applications, specifically privacy-first agentic applications. We're very excited to have the first members of the Llama herd designed to be run in resource-constrained environments beyond edge or mobile. So think commodity hardware, small research clusters, anyone on a MacBook, in general, empowering researchers or developers, regardless of their GPU or CPU footprint. And we're really excited about how this will democratize access to AI. With these new models, we're also lowering the cost of system-level safety and components that sit within the Llama stack. So with the Llama Guard 3 1B release today, we're really trying to make safety components become a more low-cost primitive that developers can rely upon. We're also very excited about enabling low-cost agents and agentic workflows. And we think about the Llama stack almost as a Unix analog for open source AI. And we're looking forward to the 1B and the 3B models, these lightweight models, playing a critical part of that moving forward. We think about the 1B and the 3B as targeted utilities. So to keep the Unix analogy going, think like sed, grep, awk. And as the stack matures, we're going to continue investing in model sizes at this scale and really listening to developers about where we can have the most impact. Previously, in Llama 1, Llama 2, we were really thinking based on a compute envelope in terms of how we would design our model scale. So thinking chinchilla laws, thinking scaling laws, thinking compute envelope, and kind of working backwards. We're now very well kind of past chinchilla optimality, trying to squeeze as much performance into a small footprint as we can, and really trying to make sure developers, regardless of the size footprint they're looking to use a model at, can really get the best, really get the bang for their buck. And ultimately, we want developers to have access to lightweight models in the Llama stack and be able to use Llama in applications anywhere, regardless of what you're trying to build. And reimagine how we can push intelligence all the way out to the edge. And when we say edge, we don't only mean mobile. We think laptops, we think one day smartwatches, glasses. The possibilities are really limitless here. When we think about the 1B and the 3B, we think about applications like summarization, RAG, so retrieval augmented generation, any sort of writing assistance, query prompt rewriting applications, few-shot classification. And I kind of like to think about these as sidecar applications. So things like, kind of as Andrew was referring to before, these like this paradigm of small models kind of acting as an orchestrator. We really think that these models can have a lot of impact in this regime. So how do we actually go about training these models? In general, we're trying to move as Meta towards a position of being towards kind of the Pareto optimality frontier in terms of efficiency for use cases. To accelerate us towards that goal, we invested heavily into pruning and distillation, really as kind of our first step in this direction. We used pruning and knowledge distillation from our 8 and 70 billion parameter models that we released first in Llama 3 and then Llama 3.1, as well as a lot of great work on synthetic data and data distillation from our 405 billion parameter open source frontier model. In terms of pruning, we did single structure pruning. So essentially, you can think about this as subnetwork initialization. And we're pruning from a much larger model. So in this case, we're actually pruning from the 8B. So we're selecting layers, we're pruning KV heads, we're pruning attention heads, embedding dimensions, as well as KV head dimensions. For parameter efficiency and memory footprint reasons, for the 1B and the 3B, we use shared embedding. So we share that weight matrix between the embedding layer and the output layer that's being used for next token prediction. When we prune in this setting, we obviously can't directly take from the 8B. If you've played with the 8B, you know that it doesn't have shared embeddings. So we have some tricks such as like weight averaging to make sure that we're able to actually get models to fit down into this footprint. And then basically, finally, we treat the output of this procedure as a really good network initialization, and then train on top of that to really extract the most out of this models at this scale. So really to kind of take it the last mile after we prune, we use knowledge distillation, both in pre-training as well as in post-training. But ultimately what we want to be able to do here is use other members of the Llama herd. So think the 8B, the 70B, and the 405B to improve our smaller models. And we think this is a paradigm that will kind of continue moving forward. For pre-training, we use traditional knowledge distillation, where instead of trying to predict the next token, we're basically trying to predict the probability distribution from a teacher model, which is a bit more of a signal-rich task that allows a smaller model to learn from. You can kind of think of it as a smooth submanifold of something that is very spiky, like the data distribution of all the internet text out there. So for the 3B, we're learning from both the 8B and the 70B. And for the 1B, we're learning from just the 8B. But for post-training, we use our largest member of the Llama family, the 405B, to produce synthetic data. And then through data distillation, we improve our key capabilities that we care about at this scale. So think reasoning, instruction following, summarization, and things that we can imagine fitting on mobile and edge devices. So globally, what does this picture look like in terms of our full training flow? The middle blue box here you can kind of think of as our internal inference stack, where we're being able to run predictions at scale. And in this case, we're both sampling for synthetic data distillation, as well as producing logits from our teacher models. So we take our pre-training data mix, we feed them through additional members of the Llama herd, so the 8B and the 70B, and we obtain logits. We obtain probability distributions from our teacher models. We then take this logit data, and we use this to obtain, through the next token prediction task, our 1B and our 3B pre-trained models. The way the models are initialized, as I was mentioning before, is we take the 8B model and we use pruning, structured pruning, single shot, as I was mentioning prior. And that's how we start the network training procedure. To obtain our instruct variants, we take the 405B, which is our frontier open source model, and we're using a mix of human data and synthetic data, and combining this with SFT and RLHF to obtain our final instruct variants of the 1B and the 3B. So how do these models perform? Within the realm of auto evals and academic benchmarks, we're very competitive in performance and on key metrics related to the use cases that we think these models are really important for, like open rewrite eval, TLDR9+, IF eval, and tool use benchmarks. We're obviously extremely, extremely competitive, punching above our weight class in many cases, in particular at the 1B scale. But really at this scale, what we're most interested in is human evals. And here is where these models really shine on a lot of the application areas that we really care about, like instruction following, summarization, and rewriting. And in particular, the 1B is really able to punch above its weight class against models more than double the size. And the 3B is highly competitive across the board. But we've really kind of focused on the areas that we think these models are particularly well suited to drive a lot of impact for applications kind of across the stack. We already use these models to great success internally for applications, as I was previously mentioning, like rewriting, retrieval, system-level safety as part of the Llama Guard 3 1B release today. And I'm really excited to see what you all as a developer, research, and commercial community are able to build on top of these models. This is really the first step for us in producing models at this size, where you can access intelligence through the Llama stack, regardless of if you've only got access to a mobile phone, a consumer-grade GPU, or you happen to be lucky and have hundreds of H100s at your disposal. I've included a QR code, excuse me, for you to download and get started as soon as possible. If you've looked on Twitter today, we've already got GGUF drops of the 1B and 3B, so people have been hard at work building on top of this already. And yeah, with that, I'd like to thank you all for your time.